Okay, in this next example here, instead of writing out the full binomial theorem, what we're doing is writing down individual terms that we're looking for. So we have the expression of x plus y exponent 15, and we're looking for the third term in that expansion. So if you had expanded that one out fully, we're looking for that third term, whatever that is. We're going to do this a faster way. We have our equation. Our equation to find each individual term was term k plus 1 is equal to n choose k, x to the n minus k, and y was exponent k. And so here we go, we have, if we're looking for the third term, that's going to be t3. But again, t is in terms of k plus 1, so really t3 is the same thing as saying t2 plus 1. And 2 is our k value. That's what we need to use in this expansion. N, of course, is going to be 15, so I'm just going to write n equals, n is 15 there. And then I'm going to start my expansion now. So let's plug in all our values into this equation. So we have t2 plus 1, that's my k plus 1, and that's going to be equal to n, which is 15, choose our k value of 2. X is just x, and we have 15 minus 2, because that's my n minus k. And then I have my y value of 2, because it's just k. Let's clean this up. Well, 15 choose 2 on our calculators should get us 105. This is x exponent 13, y squared. In total, my degree is still 15 there. But yeah, so here's the third term in this expansion. Let's find the fourth term in this expansion. So again, similar process here. We're going to write down t4. That's the fourth term, and that's made up of t3 plus 1. And again, that 3 there is our k value. We have our n value right here. That's the 7. Okay, and so we're just going to fill in our equation. So it's going to be 7, choose 3. B squared is my x value. That's going to be 7 minus 3 there for an exponent. And negative 2b is my y value, and that's going to have an exponent 3 on top of it. Alright, so from here we're just going to clean up. 7 choose 3 is just equal to 35 on our calculator. You have b squared, and that's going to have an exponent 4 on the outside there, so that's really just b exponent 8, because that's 2 and 4 multiplied together to make 8. And this last term here, I'm going to keep in brackets just because there's a negative in play. This is now negative 8b cubed. Okay. And here, again, I need to clean this up one more time, multiplying numbers with numbers, variables with variables. This gets me negative 280, because I multiplied my 35 times negative 8 together. And b's, if I add them up, I get b 11. And so that's my fourth term there. On this example, we're looking for the fifth term. So let's start this off. So this is really, we're looking at t5. And t5 is broken up into t4 plus 1. And again, 4 is my k value. My n value, similar to last question, 7. So here we go. So I'm going to go 7 choose 4. My x value is just 3x, and it's going to be 7 minus 4. My y value, that minus 2y there, exponent 4. Cleaning this up, this here on the outside is just 35. Here I'm going to leave this one in brackets just because we're doing a bit of extra work. It's going to be 27x cubed, because that's 7 minus 4 is 3, 3 cubed, and x cubed is 27x cubed. And over here, you're going to have 16, because that's negative 2 exponent 4 there, y to the exponent 4. Combining all our numbers by multiplying them all together, I end up with 15,120 x cubed y exponent 4. And that's it. That's our fifth term. In example 3, it's telling you if you had 448x exponent 6 is one of the terms in this expansion here, determine the value of b, so whatever that y value or b value in our question is. So what do we know? We know that we have this term in our expansion. I don't see a second variable here. I don't see a x, y, so most likely that b value is going to be just a number, okay? If we had x exponent 6 here and we had n here, which is 8, we know the degree on every term has to match up to n here. Right now my degree is 6. I'm missing 2, so I can do something like this. So if I have x exponent 6, I know that I'm missing a whatever your y term is, it's going to be exponent 2, and together that would get you to 8 there. So if my y term is 2 here, that means k has to equal 2. Okay. So from here, I'm just going to backtrack it into our previous equation. So our previous equation was term k plus 1 equals n choose k of x n minus k y exponent k. And again, y squared there, k is going to be our k is equal to 2 there because of that y squared. And again, how did I get that? I had x exponent 6. I know that my degree has to add up to 8. I'm missing 2, so y has to be squared. Okay, let's write down this. So we have one term is equal to this. So I'm going to start off with, instead of saying t k plus 1, I know my answer. I know the answer there once it's cleaned up is 448 x exponent 6. That's all equal to n choose k. Well, n was 8, so I'm going to go 8 choose k of 2 because we just found it. Our x value is going to be just x because that's the term there. It's just x. And it's going to be 8 minus 2 here. And then you have our b value, and that's what we're looking for. So I'm going to call it b right there in red. And b has to be all squared. Let's clean this up and let's see what we get here. Again, we have the 448 x exponent 6 equal to 8 choose 2, 28. This is x exponent 6, and we have our b squared still. There we go. Dividing off everything by 28x exponent 6, you end up with, so your x exponent 6 and 6's cancel out. 448 divided by 28 gets you to 16. So right now we have 16 equals b squared. And of course, to get to b by itself, we're going to square root both. We're going to square root both sides. So b is now equal to, and reminder that you square rooted a variable. So this is now plus minus 4. However, there's a condition here that says b has to be greater than 0. Therefore, b has to only equal 4. And that there is our final answer. In this next example, it says find the constant term in this expansion here, and here's your expansion. Constant term usually at the end there. Constant term, another hint to find it, is when you have x exponent 0. So what do we know? Let's fill in our equation. So we don't know how many, which k value we're looking at here yet. So let's find our k value. So I'm going to start off with n, I know though. I know n is 6. Choose, I'm going to put k here in red because we want to find it. Okay, we want to find that k value. Because we don't know which term gets us x exponent 0, so let's just find it. So we have x squared. This is going to be 6 minus k. And then we have our, instead of negative 1 over x, this is just negative x exponent negative 1 there, to the exponent of k. Alright, a lot of variables here to try to figure out. What we're going to do is distribute and try our best to isolate for k. So here you have 6 choose k still. This is x. 2 times 6 is 12 now, and 2 times negative k is negative 2k. Here, this term is going to be negative 1 exponent k, because that k is brought into a negative 1 there, and x to the negative k as well. And because that's a negative 1, I am going to put that in brackets. From here, can we clean up anything? We can probably combine our k's. So I have 6 choose k still, and it's k if my colors are different. I'm going to, because this is just purely a number, I'm going to bump it out front here. So negative 1 to the exponent k, because this is all multiplying, by the way, so multiplying, multiplying, multiplying. And I'm going to combine this with this here by adding. So I have x 12 minus 3k. All right. And from here, I can do something like, this where I can say these are all numbers, and I'm just going to underline it here. These are all numbers right here. This is a number, and this here is your variable. And what we wanted was the variable to equal 0. That's our constant term. So I can set this x to the 12 minus 3k all equal to x exponent 0. And now we can solve for k. Dropping my bases from previous unit, because you have the same base, I have 12 minus 3k equals 0. Negative 3k equals negative 12. So therefore k is equal to positive 4. Oops. From here, now that we know k equals positive 4, I can plug it all back into the original equation and solve for that term, solve for that constant term. So here, I'm going to go rewrite the original. So we had 6 choose, and this time, instead of saying k, we're going to say 4. This is now x squared, 6 minus 4, which is just 2, but eventually we'll clean that up. And we have that negative x to the negative, I'm running out of space, to the negative 1. The k value is just 4. So cleaning all this up, if you typed it all in, this is now 6, choose 4. This is here x, that's 4, and you'd have negative, oh, sorry, I didn't want to do that. Okay, and so from here though, sorry, I needed a bracket. If you multiply this all to exponent 4, that negative x becomes positive x. Negative exponent 4 now. Combining everything together, this is just 6 choose 4, which is 15. Your x exponent 4, x negative 4, adding that together, that's 0, which goes away as 1. So our constant term is just 15. This next example here, find the middle term of this expansion. So if you had n equals 6, how many terms do you have in this expansion? Therefore, you'd have 7 terms. As a reminder that you'd always have one more term than your degree here. So the middle term, if you have 7 terms, the middle term is T4. That's going to be your middle term. So again, T4 is the same thing as written as T3 plus 1. And so that 3 there is important because that 3 is now our k value. So let's write down our middle term. So we have 6, choose 3, x squared of 6 minus 3, and y to the negative 3 cubed. cleaning this up, you end up with, here it's just 20. This is now x to the 6. And here this is x to the negative 9. Combining our x's together, we have 20x to the, oh, sorry, I'm missing a negative here. That becomes negative x, so that's become negative 20. 6 and negative 9 makes negative 3, which again, I don't really like a negative exponent. So that's a negative 20. X cubed in the denominator, making it positive. Finally, our last question, the expansion has 53 terms. What's the value of m? If I know I have 53 terms, my degree is always 1 less than it, therefore n had to equal 52. If I'm looking for m here, m's in our exponents only, I can say 52 is equal to 2m plus 4. Isolate for m here. So we have 50, oh wait, no, not 50, we're going down, so that's 48. 48 equals 2m, so therefore m has to equal 24. Alright, that's the end of our lesson. If you have any questions, please feel free and ask.